All right, we'll get started. So, as usual, we're going to go to the GitHub page for the course. And today is lesson 10. So we're halfway through after today. And so today's lesson is a crash course on NumPy, pandas, and matplotlib. So we will copy this notebook to our working directory. So let's click on this raw link. You'll see that the notebook here is shown in its true format in it's called JSON format. So we'll copy that link, go to our terminal, and we'll change to our lessons folder, and then we can do curl dash capital O, paste that link. That will download it. And then we'll do our source activate Python 3 environment. And then we can do in our Jupyter notebook. Okay. So we want lesson 10. All right, and then before we get started, let's clear the output so you know that everything is working correctly on your machine. So we're going to go to all output and clear. And I will hide these. Yeah, I'll leave that one there. Okay, everybody good? So, as I said, we're going to do NumPy's, pandas, and matplotlib sort of crash course. So this is just I'm going to throw a lot of stuff at you that we'll then come back to in the next 2 weeks. So next week we'll do NumPy and pandas. Then the following week we'll do matplotlib and a related package called Seaborn, which are for plotting. And then we'll go back and do some more pandas, because pandas is a huge package. It's kind of the, like, when I'm doing data analysis with Python, I'm pretty much like in the pandas world. Lots of cute little black and white bears all around, and just having a blast doing data science. So, all right. So NumPy is we'll start with NumPy. This is a core numerical computing package in Python. So this is actually what pandas is based on. The main data type in NumPy is called the ND array, or n-dimensional array. Then pandas uses the main data type in pandas is a data frame, which is like a table or an R data frame, and then a single column of a data frame is its own data type, which is called a series. And pandas supports these really powerful SQL-like queries. And then matplotlib is a package for plotting and has this MATLAB kind of syntax. So if you're familiar with MATLAB, you'll be able to pick up matplotlib really easily. So first of all, NumPy. So there's basically 3 types of arrays that we use in the standard Python variables. We've covered list, tuples, and dicts, which are like a hash table. And lists are kind of what arrays are. Arrays are a type of list, but they have a lot more functionality. And the advantage of using NumPy arrays or something built on that, like a pandas series or data frame, is that they're more high performance. They support a lot more operations. They're statically typed instead of dynamically typed, which is more restrictive, but also gives you a lot more speed. We'll cover some of those features here. You will use NumPy sometimes in your day-to-day coding. Sometimes you definitely have to use it, but it also is nice to understand how it's working, because this is really like what's happening under the hood if you're using pandas. So first thing we'll do is import NumPy as NP. Did that work for everybody? Okay, good. That means you have it installed. So to create a NumPy array or an ND array, there's a few different ways we can do it. We can either convert from a Python list or a tuple, or we can use a function, a NumPy function that will create an array for us. There's one called arange, which is similar to range in Python, or linspace, or we can read data from a file. So from a list, we simply take a list. So that this is here in brackets. This is just a list of integers, 1, 2, 3, 4, and then we wrap that in this np.array function. So remember, with Python, it's an object-oriented language, so we imported NumPy as np. So np is this module that's in our namespace, and then when we type np dot something, it's some attribute or object or class within NumPy. So this is a class called array, and so we can then just run this function and we get this array. And if we wanted to verify what that was, we could do type v, and it's a NumPy ND array. But when it's shown on your screen, it'll just show as array. So we can make a matrix, which is just a two-dimensional array, and we can do that by passing a list of lists that has this matrix-like shape, and we can see that it gives us an array that's a two-dimensional array. And again, both of these are ND arrays, and we can, if we want to figure out what the dimensions of an array are, we can use this shape property. So we type v.shape or m.shape, and that will give us the dimensions of this thing. So it's either this first one is just 4 by 1, so it's just shows up as 4 comma no, blank, and then the matrix that we made is a 2 by 2 matrix. If we want the total number of elements, we can use this size property. So we can do m.size, and it'll give us the size. Alternatively, there's another, we can sort of flip this thing around. Often in Python, you'll have both a property of an object that you can use, like that you can call, like here where you're taking the object dot size and it gives you the size. You can also use a function that's np, so this is the NumPy function shape, and then do it that way. It gives you the same output. It's just a different way of getting that information, and depending on your style and maybe the situation you're in, one or the other might be more natural. So the advantage of using this NumPy ND array relative to a Python list is that one is that they're statically typed as opposed to dynamically typed, and so you can imagine we discouraged making lists with numbers and strings and all these things in the same list, but it's possible. The problem with that is if you try to do like matrix math with a list that has strings and other lists and dictionaries in it, like it's not going to work. So NumPy is more strict on the data type, so they have to be homogeneous. So you can have strings, but then your array has to have all strings. You can have integers, but the array has to be all integers. This is similar for pandas with these columns in the data frame that we'll see. You have to have the same type, and in fact, Pandas supports even more types of columns. But so this gives you some advantages and speed, in addition to the usability and functionality. So if we want to know what type of array it is, we can use this dtype property. So this shows us that this M array, this two-dimensional array or matrix that we made, is an integer data type. So if we were to try to assign a string to that, it would give us an error and say this is an invalid literal for integer with base 10. However, if we try to assign an integer, it'll work. And you can see that M has now been updated. It used to be 1, 2, 3, 4, and now it's 5, 2, 3, 4. And this little index that we provided says it's in position 0, 0, which is that first row 0, column 0. And when we create an array, we can actually explicitly specify the data type. This is also, we have this option in Pandas when we create something. Sometimes, for example, you might want the numbers that are in your spreadsheet to be rendered exactly as they are in your spreadsheet. Say you have a CSV file and you're importing it. If you want to make sure that those numbers are not sort of interpreted in any way by the import, you can import them as strings. And so they'll just be imported exactly as they are in your file, and nothing will be changed. Now, you can't do all the things you can do with numbers with strings, or in Pandas it's called just an object, is a generic name for a string. But there's reasons you might want to specify which data type. Otherwise, NumPy or Pandas will just infer what type it is. So in this case, even though we passed a list of lists, we said we want the data type to be complex, or complex number. So it's showing it as this I plus j, so this real and imaginary component to these numbers. So these are complex numbers. So we can force it to do that. So the common ones that you'll see would be integers, float, complex, bool, object, which is string, etc. And you can actually specify the bit size if you want. Typically that's not needed, but it's available. So we saw the Python command range, which gives us a range from 0 up to, but not including the integer that's given, and you can also specify the start and stop and step. There's an analogous command in NumPy called arange. So this will go from start, stop, and then the increment, or a step. So it's going from negative 0.5 to 0.5 to 0.1. Now, you can see it's showing these as in scientific notation, so these are sort of floating point values. In fact, we can verify that by doing x.dtype. So it's float. Does anyone know what this value is? 0, right? More or less. It's really close to 0. So I don't have a degree in computer science, so I don't exactly totally understand the details of this, but basically to speed up the calculations, floating point values are not stored in exactly precise fashion. It's an approximation. So this is an approximation of 0, which makes it faster. For most purposes, it won't matter. This is 10 to the minus 16th. It's infinitesimally small, so it's basically 0. But anyway, that's just, if you see things like that, that's what's going on. Don't worry about it. For most cases, it won't matter. And if it does matter to you, you can use integers and sort of deal with it that way. Well, it's the scientific notation is just that's how it's rendering it. But if you, it's actually normally this is hidden from view. If you saw, it would not display like those digits, so you would just see it would look like it was. Yeah, there might be a way to change how it's rendered, but this is showing you how it's stored internally. In fact, doesn't. I was wondering if it might change if I did it again, but it doesn't seem to be random. There's another function called linspace, which is similar to arange, but with arange you don't get the last value. It works like range. With linspace you do. Also, it works differently. Instead of this last value being an increment, this is a number of values. I should add that in. N. So you can see there's 25 values in this array, and they are evenly spaced from 0 to 10. So here's a case where these are all floating point values. It's just rounding them to the nearest value, and it's possible that some of these are stored in, they're not precisely exactly, but for the purposes of your calculations it won't matter. There's a if you've used MATLAB and you've used this function called mgrid, there's a similar or meshgrid, there's a similar function in NumPy called mgrid, and this will give you these two matrices that are sort of inverses of each other, which is useful for some linear algebra applications. There's also random number generation capabilities that are more sophisticated than what we've seen so far. So you can use this rand function. So so we're starting to see more of this object-oriented system. So NumPy has a sub-module or subclass called random, and within that there's a function called rand. And so we can specify either a one-dimensional or two-dimensional or more vector or array. In this case it's a matrix, 5 by 5 matrix of random numbers from 0 to 1. If we wanted normally distributed, we could use rand n. So the n is for normal, and so you can see these are centered around 0, but some of them are greater than 1 or greater than or less than -1. So it's a normal distribution. You can create a diagonal matrix like with this function diag. Another really useful one is zeros or ones. And if you wanted integers, you can specify the data type as int. So this would be, if you wanted to initialize an array with zeros or ones, this would be a good way to do it.